Welcome everyone. Thank you for joining us for today's expert webinar titled SQL Joins and its Type. I am Ria from SpringPeople. We are India's largest enterprise training provider, and I will be your moderator for today's session. In today's session, we have Mr. Parul Kundra with us, a prominent figure in the world of cloud computing and AWS. With an illustrious career spanning over 15 years, he boasts a remarkable list of qualifications and accomplishments. Mr. Kundra's skill set extends to SQL and PL/SQL, demonstrating his prowess in database management. He is also a proficient problem solver using Python, C, and C++, and has a solid grasp of data structures, showcasing his versatility in the world of programming and technology. Having conducted over 100 AWS corporate training sessions, Mr. Kundra specializes in preparing individuals for certifications such as Solution Architect, Advanced Architect, Cloud Practitioner, and System Operation Associate. His training methods are renowned for their effectiveness. To all the participants, you can mention your questions in the chat box and it will be answered at the end of the session. Now, without further ado, let's start today's session. I would like to invite Mr. Parul Kundra to start the session. Over to you, Parul.
Thank you, Reha. Am I audible, everyone? Reha, am I audible to you?
Yes, Parul, you are.
Thank you so much. So I welcome you all on the webinar on SQL and its types. As Reha already mentioned that I'm in AWS, taking so many batches on AWS. We'll do something different today, that is on SQL. And if I talk about SQL joins, it is one of the very, very important topic, widely asked, widely used, and highly confusing topic. So as we are here from 4:30 to 5:30, so this 1 hour is not going to be too sufficient for covering everything, all aspects. But here, what exactly we are trying to do is that we are going to build your understanding on joins, why we need joins, what are different types of joins. In future, we'll be also planning with case studies, scenarios based, and where to use what joins and all. We'll be doing that. But today we are starting with the topic called SQL and its joins, SQL joins and its types. So let's start with the agenda. The agenda here, we are going to talk on inner joins. So inner will talk on cross join, equi join, natural join, self join. This is what we are going to cover, not theoretically but practically both. So both theory and practically we are going to see what exactly these joins are. And then we'll be also talking on outer joins, that is left outer join, right outer join, and full outer join. This is going to be the agenda of today's discussion. Let's start with the discussion. Okay, so SQL joins. If I talk about SQL joins, so SQL join clause is used to combine record from two, or it can be more than two tables. We know in database we create table. We are talking of relational database. We create table in a database. Now a join is a mean of combining field from two tables by using values common to each and all. Fine. Now if I talk about reason for joining, now why exactly we are looking for, why we need joining. Without joining, can't we do our job? Is it really mandatory to go for joinings, so to go for joins? So we join two or more than two tables if information needed is scattered among different tables. So what exactly I wanted to say here by this line is that I am looking for an information, but that information I cannot get from single table. That information is scattered in more than one table. So in that case, I may be needing more than one table to fetch the information. So when I'll be needing more than one table to fetch the information, in that case, the concept in SQL is joins. So we join the table. Now, if I'm giving you a simple question, the question is that find the name of employee having salary greater than 25,000, and I have two tables. Table one is employee table and one is department table. And the question is this: find the name of employee having salary greater than 25,000. So I'll simply write a query, select name or ename, whatever the query is, ename from table name is imp, where salary is greater than 25,000. So I'm not looking any kind of two tables. With one table only, I'm able to solve this question. So with only one table, I'm able to solve the question. It's of nowhere I'm looking for two tables. If I go with next question, find the department. So here, if I talk about the first question, so the person who are getting salary more than 25,000 is a Smith and Ricky and Tom. They are getting this. So if I run the query, I'll get the answer. And only one table is required. If I talk about second example, to find the department of employee having department ID equal to 03. So I wanted to know the department whose department ID is 3. So I'll simply write a query, select department from select DEPT from department where department ID is 3. So I'll be getting answer as training. I'll be getting answer as training. So training is what I'm getting. In this question also, in this example also, I don't require two tables. But now if I give you the third question is find the name of employee working in training department. So if I consider only employee table, and by watching this table, I need to know the name of employee working in training department. Here I have only three information. I have name employee and their salary. About which department they are working, I don't have any information. If I see this table, I have employee ID and I have department and department ID. So I have a department, but I don't have employee name. But here I wanted to know the name of those employee working in training department. So one information I have here, Now I have information scattered. This is what I wanted to tell you. I have information scattered in two tables. Now these two tables have information which I exactly wanted to know from question number 3. So for this kind of situation, I need to join my table. So I have to join my table. Coming to the next slide. So as the agenda was for inner joins and outer joins. So coming back to the agenda, inner joins. So inner joins, we do inner joins which returns only the matching rows, and you can go with joining up to 256 table using at the same time. So inner join is showing you a Venn diagram where there are two tables. Let's say it's table 1, it's table 2, and I want some value which is matching values from both the table. So I'll be getting this information. So when I go back to the question, now I want the name of employee working in training department. So if I talk about employee ID 1 is a John, but employee ID 1 is working in research department. Employee ID 2 is a Smith. Employee ID 2 is working in training. So overall, I can say that Smith is working in training, and I can say even Tom is working in training because employee ID of Tom is 5 and 5 employee ID is working in training. So this is what I'm getting the answer, that Smith and Tom. But we are not going to watch the table and calculate the values. We want some queries because here it's 5 values. My table can have 10,000 values. So for 10,000 values, I'm not going to do the things manually. Either I will ask my SQL engine, I'll ask my SQL to do it for me. So that is what inner join, we find the matching value. So where we are finding the matching value. So 2 was matching with 2 and the question was training, I'm getting the answer, and 5 was matching with 5 and the answer question was training, so I'm getting. So exactly in the same sense, you get other matching values. But if I talk about inner joins in DBAs, so we will talk today on cross joins, equi joins, natural joins, and self join. And outer joins, what is outer join? Which now in some scenario, we may not need only the matching value. We may need some extra value as well. So for that case, you can go with outer join. So in outer join, return all the matching rows plus non-matching rows from one or both the tables. So it's up to you. So you can perform only two tables or views. You can say it's a part of table, or a view is a concept which we'll discuss somewhere later. So can be performed on only two tables or view at a time. So outer join can only be done on two tables, while inner join 256. So okay. So in outer join, we have left outer join. So in left outer join, what answer we get? We get matching values. Other than that, we get value of left, complete value of left table. Means, let's say we have two table, table 1 and we have table 2. Now we are doing a left join. So when we are doing a left join, so what we get what value of table 1 is matching with what value of table 2, that is this value. Along with that, we also get all the values of table 1, left table. Now, if I talk about right join, so in right join also we get all the matching value. Along with matching, we get all the values from right table. Again, I'm saying there are different scenarios where you can use this. Fine. Today we'll understand what these types are. Somewhere later point in next webinar, we'll be talking on different scenarios, questions, and everything. In full join, we may get values from all the tables. So table 1, table 2, and we get values, matching values from the tables, as well as non-matching value from left table, as well as non-matching value from right table. So in outer join, we have three type of join: left outer join, right outer join, and full outer join. Now we'll start with the prerequisite of joining. And the prerequisites of joining is Cartesian product or cross join. So we'll start with SQL cross join. Let's start. So cross join, or you say Cartesian product. So to understand SQL process, to understand how SQL process a join, it is important. I told you, it's core component to understand the concept of the Cartesian product. So it is very important to understand what is Cartesian product. So a query that lists multiple tables in from clause, so where we'll be using from clause, without where clause, produces all possible combination of rows of all the table. This is called Cartesian product. Now you must be thinking, what you're explaining, we are not getting anything. This is theory. So never go on theory. We'll do it practically. So what exactly this line is trying to tell you is that where we get multiple values from tables, where without applying any where clause, where conditions. So you know about query. So if I wanted to know the name of student who are having a roll number greater than 24, so where we'll write select name from student where roll is greater than 24. So here I'm using where clause. So where will automatically reduce some values, but I want the full set. So when I want the full set, in order to check, we'll go with Cartesian product without where clause. So select star from table 1. So this is, let's say, for my first table, comma table 2. So this is called your Cartesian product or cross join. Or if I say select start from, instead of comma, you can also put cross join. So it's up to you. You wanted to put comma or you wanted to put cross join, you will get the same result. Now see, do we have two tables, table 1 and table 2. So table 1 needs to be cross joined with table 2. So what? So now this first value will match with all. So the table 1 will, the first row of this table will match with this. So like this, you can see this. So I have total now three values. So this one value is product multiplied with or cross joined with all the three values of table 2. But again, this value will again be multiplied. So this. So again, for 4 you get all the values 2 3 5. Now with this row also, it will be taken a Cartesian product. So 2b will be multiplied with this and this. So overall, what I wanted to show, or what I wanted to tell you, when you go with cross join, so what you apply the all possible combinations. So you're applying all the possible combinations. So overall, if you have three columns in your first table, you have three rows in your first table, you have 3 rows in your second table, the number of rows you get is 9 rows that you get in your result set. Other than that, you also get number of columns. So 2 columns here, 2 column here. So overall you get 4 columns. So this is what the result you get. This is how you get the result of your cross join or your Cartesian product. Now, I'll not go to natural join. I first love to explain you what exactly I'm trying. So this is where I will execute my query, and I'll be showing you. So I'm going to execute the query and I'm going to show you. So let me show you one table. So my one table, I'm going to show you cross join. So what is, let me show you first table. So select star from student SpringPeople. Fine, SP. I created one table with student SpringPeople. So let me click. So student student. I'm so sorry, student SpringPeople. So you can see my table. So I have a table having 3 columns: roll number, name and address, 1 Parul, Noida, 2 Amit, Ghaziabad, and Rohit, Delhi. And now I have another table also, course. So let me select the values, select everything, star from second table. Second table is course, COURSE, SP, SpringPeople. So you can see, so we have course number 11 for AWS, 12, 13. Now, if I have to do the Cartesian product or cross join, now you must be thinking, why am I doing cross join? I'll be telling you. If you know, that's good. If you don't know, I'll be telling you. I'll be telling you that. So what am I going to do? I'm going to do cross join. So how to do cross join? So select star from what? First table. So first table is student SP SpringPeople. Second table is course SP. Simple. You just put comma, and this is how star means everything. You wanted to find everything from a table. So let's see what happens. Oh, yes, you can find the 9 values. 1 Parul matching with 11, 12, 13. So 1 Parul Noida is matching with 11 AWS, 12 Azure and SQL. 2 Amit is matching with all, and 3 you are total getting 9 rows. This is how the Cartesian product is working. Or what you can do, instead of comma, you can overall write cross join. So you write CROSS cross join. So if you write, you'll get the same result. So either you put comma or you put cross join, you get the same result. This is what a basic. This is a prerequisite of understanding joins. So prerequisite is this. Now what next? The next is I'm going to show you. The next is this. So after Cartesian, understanding Cartesian product, so I have shown you my 2 tables. I have cross-joined those table or took the Cartesian product of table, and I'm having a result. Now what next? I'm going to show you the natural join. Now what is join? Actually, let me tell you what is join. So join is nothing but a Cartesian product plus some condition. So always make a note of it. Join is nothing but a Cartesian product. So till now we have understood Cartesian product or cross join. Now when on cross join, I'll put some condition. Then this will actually form a join, and then types of join we'll discuss. So from that join, we are going to understand SQL natural join. What is natural join? So till now we have understanding of this. Now we'll put some condition. So natural join. So first natural join, let's understand natural join. So natural join, it does not utilize any comparison operator. First of all, here will not use any comparison operator, equal to, less than equal to, or greater than equal to, nothing. In natural join, there should be at least one. Please make a note of it. There should be at least one common. So when you are going to apply natural join on, so when you are applying natural join on 2 tables, join means you have more than 1 table. So when in natural join, there should be at least one common attribute or column. Attribute is called column between 2 relation means table. So when you are doing natural join, so make it sure there should be at least one common column in 2 relation or 2 table. Then what you do, it performs selection. Then you perform selection, equality on common attributes. So on the basis of common attribute, you will select something, and that is which is appearing in both the relation. And also it eliminates duplicate value. Again, so much theory. Why so much theory? We are not understanding. Can we explain everything in practically? So again, practically in PPT also, practically on your SQL also. So fine, we'll do that. Now see, now I have an employee table, I have a department table. As employee 1 having getting a salary 20,000, his name is John. Employee 1 is working in research department and his department ID is 2. Now find the name of employee who work for any department. So I wanted to know the employee who is working for any department. So John is working for research department. Smith, employee ID 2, employee is working for training department. While if I talk about Shane, Shane is getting a salary, but he's not working in any department. Yes, it is quite possible. Shane is a recent joiner. He joined one day back. Now he has not been assigned with any department, let's say. So he is just in a voting, or he's on a bench or something like that. So, but the question is, find the name of employee who work for any department. So as of our understanding, by watching a table, we can say Shane is not working in any department. But watching is not everything. Here we are not watching anything. We have to apply a query. So by watching, so we can easily say, but again, same thing. If there are 10,000, 20,000 values, so by watching, you can't do anything. Fine. So now what I'll do, will do a cross product. So what I did a cross product. So you see, so cross product means first matches with this, first matches with this. Again, second matches with this, second matches with this. And then third matches, and like this, the matching is done. So overall, what we did, let me show you. So what we did a cross product. So what I did, so you just understand only this part, only this part. So what till now, whatever the answer which you are getting is this. So select star from imp comma department is a cross join or a Cartesian product. You are getting an answer. 1 John 20,000 20,000 research training this. Now above that we are applying some condition that where employee imp dot employee ID, that is imp table employee ID is matching with department table employee ID. So when we'll apply this, so what answers we are going to get? So imp dot employee ID. So imp employee ID is 1 is equal to department employee ID. Yes. So accordingly, I'm going to get answer this. Imp dot employee ID is this. This is imp table and this is department table. This is matching with this. No, this is not. So not this. Imp dot employee ID this is matching with this. Answer is no. So answer no. Is this matching with this? Yes. The answer is this. Is this matching with this? No. No. So this too is not. So two things are coming. So one this is coming and one this is coming. So what exactly I'm going to tell you is that select start from imp comma department where employee ID is equal to department ID. So what we'll get? We'll get this. So we are getting this. But our question is what? I wanted to know the name of employee. I wanted to know the name of employee who are working in any department. So what? We'll put some, we'll put, or what we can do, see, either you put Cartesian product, or what you do, you write natural join. So if you write imp in place of comma, you write natural join. So what will that? Again, you will get the same answer. Also, see, here you are getting duplicate 2 times employee ID. But in natural join, it will eliminate the duplicate value. You will only get 1 time employee ID. So now coming back to the definition, you see the definition. So the definition is saying it's duplicate at eliminate duplicate attribute. So with natural join, if you are doing a cross product, it will give you all the values. Fine. So previously we were doing only cross product. Now we are applying some condition also. But in place of cross product or Cartesian, if I'm using natural join between 2 tables, so what it will do, it will give me a same result. But here the common column which is there will come only 1 time. And condition is that there should be 1 common column in both the table. Yes, employee ID is there. Now I wanted what I wanted. So I'm expanding my query. So the query is that, okay, fine. What you did, you after from what you did, you cross product 2 tables. That is fine. But we don't want star. We don't want, you see this here, I was looking for everything. So I was getting every column. Here I'm not looking every column. I'm looking for imp table employee ID, then ename, and then department. So I want only 3 columns, not all 5 or 6 columns. So when I'll run this query, I'll get this. So I'm getting an answer, EID, ename, department, and this value. So because I'm getting 3. Now you must be thinking, why imp.eid? Why only ename? So please understand, EID is in both the table. So query will get confused. So what EID you are talking about? You want EID of this table or you want EID of this table? So for that you will write imp.eid. That is, I want EID of imp table. But here I'm only using ename because ename is only in one table. So ename is only in one table. I'll only take ename. Department is only, DEPT is only in one table. I'll go with. So when I'll run this query, I'll get only the selected columns. So I'm getting a selected column, or you can do this query with this natural join. So you are doing a natural join with department Fine, natural join, but you want columns, employee ID, ename, and department. Here you need not to do any imp.eid. That is what I wanted to tell you about natural join. So here you simply put eid, you will get the answer. Fine. And what answer you will get this. So let's do it practically, understand natural join. So what am I going to do? I'm going to explain you natural join. So let's do a natural join. So I have a table. So select star from EMP SpringPeople, employee of SpringPeople. So you can see we have 1, 2, 3 employee ID 1, 2, 3 of John, David, James, and they are getting some salary. Now we wanted department, so we are going with department. So department. So we'll go with what department SpringPeople have, DEPT. So DEPT SP. So we can see SpringPeople have research and training department 1 and 2. Now question is, I wanted to know the name of employee who are working in any department. So if I'm joining these two tables, so what you can do, you can simply do select star from what I'm doing, just cross product from EMP SpringPeople, comma DEPT SpringPeople. Fine. And you are just doing a Cartesian product. So when you are doing a Cartesian product, you will get the 6 value. But this is not my result. I wanted to put some condition that I wanted to have the information of those employees who are working somewhere. Fine. So here I'm getting the name of John, I'm getting a name of James also, but James is not working anywhere. He has not been assigned any department. So now I'll put some condition. So after this, I'll put condition where imp SpringPeople dot eid is equal to what? Which table? DEPT department SpringPeople eid is equal. So when their IDs are equal, on that condition I want the result. So when I run this, so I'm getting, oh yes, I'm getting a result that John and David are only the 2 employees of SpringPeople which are working for some department. While if I talk about James is employee ID is 3, he's not working right now anywhere. But I don't want this complete information. First of all, forget about complete information. What I can make this query so short. So instead of this comma, I'll put natural join, NATURAL, natural join, and I'll not write any where clause and all. No need to write any where clause and all. So you just put natural join and see you are getting the same result. So in normal case, you are putting so much efforts. Natural join automatically applies to a common columns, and see you are not getting a duplicate value. Here you are getting employee ID 2 times. Here you are only getting employee ID one time, and that too automatically, no condition required, because natural join is itself has a condition that you can apply natural join on 2 table which have common column. So here in 2 table I have a common column, I'm getting a result. But I don't want everything. I don't want star. So if you don't want star, what do you want? So I want employee ID, I want employee ID, I want employee name, so you can say ename, and I want department DEPT name. So I want DEPT name. So if I put this, so I'm getting no need to write imp.eid. But if I write here, see, if I write here the same thing, I want imp ID, I want EID, sorry, I want EID, I want EID, I want ename, and I want, let's say, DEPT name. If I do somewhere in Cartesian product, it will get confused. So it's like ambiguity defined. It is saying EID. Which EID? 2 table has EID. Which table you are talking about? Now I have to say, oh, I'm so sorry. So when you're not going with natural join, you have to specify, oh, for imp SP table. So for employee SpringPeople table dot EID. So I am looking for employee ID of SpringPeople table. Fine. So if I get, now I'm getting a result. So this is what you can go with natural joins. Coming back to the next and very, very confusing, and I'll make very clear for you from today onwards, you are not going to forget that join, and that is self join. Self join. Now the question is, hey Parul, what is self join? Self join, when you join a table with itself. But Parul, you just now when you started your, the class, the webinar, you said in order to join, I should have 2 tables, at least 2 tables. No, only then we can join. But now you are saying you have only 1 table, and you want to join it. And for what purpose you want to join a single table? I'm not getting. I'm not having any idea what exactly you wanted to teach here. So if you don't have any idea, within 10 minutes, you will become very expert in self-join. Let me tell you. So it is going to be the easiest thing for you to understand. So, okay. So what in self-join? Okay. So what is self-join? The SQL self-join is used to join a table to itself, as the name says, self-join, as if the table were two tables. So it will, you will assume that that table are two tables. Temporary, what we'll do, will temporarily rename at least one table in SQL statements. What we'll do, we'll do a alias. Well, we'll do a alias. Now, what is alias? Second name, will give it to the table. Now, how this works? So syntax is something like that. Select column name, whatever, from which table? Table T1. So table 1 T1, table 1 T2. You know what will happen? Table 1 T1, it will create one T1 table of table 1, and it will create one T2 table of table 1. Now, whatever where condition you wanted to apply and apply. And here it is saying that T1 and T2 are alias. Fine, alias of table 1. So they are names of alliance. So let's say in my class there is Rahul. Fine. So there is Rahul. I say Rahul. So Rahul might be having an alias. So Rahul might be called, so his friend might be calling him bro. Fine. While his parents might be calling him some name by let's say John, Johnny, something like Johnny. So the alias of Rahul is bro and Johnny. Fine. Exactly in the same sense, either I call bro or I call Johnny, but it is representing Rahul only. So either I called T1 or I called T2, it is representing table 1 only. So that is what we are doing a alias. So what is that? How to do that? And Parul, what are situations? I'm going to show you. Now see this. We have imp table and we have only imp table. So we have imp table, and what we did space E. So I have an imp table, and you read this table. Employee ID 1 is working in research, and he joined research department in 2012. 10. Employee ID 2 is working in defense, and he joined the defense department in 2015. While the same employee ID, let's say employee ID 1 is of Rahul, Rahul again Rahul joined training department in 2020. Forget about Rahul, think of me, I am Parul. Till now, I was dealing with AWS. So I joined SpringPeople few years back. I was only dealing with AWS, but now I got one new role today that I'm taking SQL also. So I'm taking SQL also. So the same person is taking working in more than one department. It is quite possible. A person who is expert in testing, a person who is expert in prod can work in more than one department, can help, can assist. A person must be a very good in cloud also, and person must be very good in coding also. So he can help organization for both two department, but he's the same person. So now what I did, I created two table with two different names. So imp E means table is imp only, but the new name is E. Table is imp only, but the name is F. Now I want to know the employee ID and department name of those employee who work for more than one department. See, now in this case, you have to use self-join. See, the question, what a beautiful question. You wanted to know the employee ID and department name of those employee who are working in more than one department. There could be multiple scenarios. In next webinar, we'll be dealing with those scenarios. Today, we are understanding joins. So see, I'm giving you one scenario that you wanted to know the name of employees who are working, who wanted to know the employee IDs of those employees who are working in more than one department. So by watching a table, you can clearly say that Parul employee ID 1 is working in more than one department. Employee ID is working in research also, and employee 1 is working in trading also. Again, I'm saying, please, it's not a 3-value table. It might have 20,000 values. It might have 1 lakh values. And from 1 lakh value, you need to figure it out. So what? You will not go and scroll, scan the table like this. This is not your job. You want query to work for you. So if you want query to work for you, let's say in a SpringPeople, there are 20,000 employees, and out of 20,000 employees, 1,000 employees are working in more than one department. Now it's appraisal time. Now SpringPeople wanted to give a good appraisal to those employees who are working in more than one department. So what do you think? HR will go and check their names, they are working in 10 departments. HR will simply, we have a Rhea here, so she'll simply apply a query and she will get the name of those employees, employee IDs, and definitely I can expect a good increment next time. So that is what I wanted to tell you, a query. So the query is, so by this query I'm communicating to my company also. Just joking. So find EID and department name of employee who work for more than one department. They are working in more than one department. So what exactly the thing is this? The query is select E.EID, means I have one table whose name is E. From that I want employee ID. I have another table, I have a same table, from that I want department name. Now what am I doing? I am, what is this? I'm doing Cartesian product of two tables. So E table and F table are cross joined with each other. So when they are cross joined, after cross joining, I'm applying a condition that their employee ID should be equal, but their department name should not be equal. Fine. So who are those employees? Their employees are ID is equal, but their department, that is, they are those employees, their department names are not equal, but their employee IDs are equal. Means they are working in more than one department. That is what this query is. This is not equal. This sign is not equal to. So, okay. So again, I'm explaining you the query. Try to understand. This query is saying, hey, Parul, what do? You do a Cartesian product of two tables. Again, I am telling you, what is join? Join is nothing but Cartesian product plus some condition. That's why in my first topic, I have explained you Cartesian product. So imp E is Cartesian product with imp F. That is two same table with different names are multiplied. So we'll get total 9 values. On that 9 values, we'll apply a condition that their employee ID should be equal, but their department name should not be equal. So let's see this. So we have two table. One table is imp, their alias name is E. Another table is also imp, their employer's alias name is F. Now what am I doing? I'm doing what? Cartesian product. So please see this. You see only this part first. Forget about this. So first from executes. So imp E and imp F. So what will happen? So you know that this one, this, let me change the color of my pen so that I can explain you very clearly. Now what Cartesian product, this one will get multiplied with this also, with this also, with this also, like that, with then two will get multiplied. So what exactly we are getting? One research 2010, one research 2010, one research 2010, two defense 2015, one research 2010, one training, two, like this, two, like this, one is multiplied. Now, okay, what after that? Now the query is, so from executed, so from executed. Now after that, where will execute? So in where I have a condition where EID, so this is E table and this is F table. So what I'm saying, EID is equal to F dot EID. So this is equal, yes, but their department name, E department name should not be equal to F department name. So now I check department name research and this is research. No, it should not be not equal. It is equal. So cross, I'll not take this. Now again, I'll go. Is this equal to this? No. First condition is false. So in AND gate, you know what is AND gate? AND gate. So AND gate is only true when both the condition is true. So this is AND gate. So we are using AND, not OR. Okay. Now again, is this equal to this? Yes. Is this not equal to? Yes, this. Yeah. So I'll select this. So overall, what am I getting? One row is selected. Again, is this equal to this? No, this is not equal to this. Again, first is not correct, then I'll not go for second option. Is this equal to this? Yes. Is this not equal? No, this is equal. Is this equal to this? No, this is not equal. Fine, I'll remove. Is this equal to this? Yes. Is this not equal? Yes, this is not equal. So now, is this equal to this? No. Is this equal to this? Yes. Is this equal? Is not equal? Now it is equal. So we are, so overall two rows are selected, and on these two rows, now this part will execute. I want EID and I want D name. What? E dot EID. So E dot EID is 1 and department name, E dot department name is research, and E dot, and which is selected, this is selected, E dot EID is 1 and department name is training. So you can see that employee ID 1 is working in two departments. So that is what I'm getting. Yes, and he will get an appraisal because employee ID 1 is working in two departments and I'm getting a good result. And yes, I'm getting a good result. I'm okay. I'm happy, very happy with that. Fine. So yes, you are getting, yeah, see, you are getting an answer. One, research and training. Now this will help our HR to get a correct information. Now, before I go to EquiJoin, as you know my habit, so what I'll do, I'll show you the things practically. So I'm going to show you the self join practically. So for self join, I have a table called imp self. So select star from EMP imp self. So you can see employee ID 1 is working in research. He joined the department in 2010, but in 2020 he started working in training also. Fine. So you wanted to know the person who are working in more than one department. Again, you have to apply a self join. So what is the query? Select what? I want E dot EID. You know what is I want? So what is E? E is a one table. E is the name of a table. And I want E dot D name. So I want D name from E table. Fine. After that, what exactly I want? I want, so now I do a Cartesian product. So I do a Cartesian product of what? Two tables. So I have only one table. So you have to give a alias. So what? I have to give a alias, that is imp self. You give it E, comma, this is Cartesian, imp self, a second table, and you give it F. So what I did, I created two tables of himself. One table name is E and one table name is F. Now I have to apply a where clause. Where E dot EID should be equal to F dot EID. ID should be equal. Obviously, the person is same, but department should not be same. And the person is ID is same, but he's working in more than one department. When he's working in more than one department, his department name should not be same. So E dot D name should not be equal to F dot D name. Simple, comma. So imp, so it's imp self, not E self. So I have written a wrong, EMP, imp self. Now let me run the query, and yes, so he is employee number 1, employee ID with value 1. He is working in training and he is working for research. That is what I wanted to teach you, and this is completely understandable. Fine. Now we'll move to the next topic, which is self-join we completed. Now we'll move to self-join we have completed with good understanding. We'll talk on EquiJoin. Now EquiJoin, if I read a query, so EquiJoin is done when theta join uses only equivalence condition. So theta is something where theta, it can be equal to, less than, greater than, but in EquiJoin we use only equal condition. So EquiJoin is so only we use equivalence condition. EquiJoins is most difficult. Nothing is difficult. Operation to implement in RDBMS. And inner join or EquiJoin is, so either you call it inner join or EquiJoin, is a comparator based join which uses equality comparison in inner join predicate. So we have some predicates, these are predicate, and we use equality condition. However, if you use other comparison like less than, greater than, then it cannot be EquiJoin. So it is not equal join. Now you must be thinking that, Parul, we have already used equality in natural join. What is new here? So please make a note of a difference between natural join and EquiJoin. In natural join, equality is applied on two table having common column. That is, one table should have a common column and second table should also have a common column. If here is roll number, here should also be roll number. Here is employee ID, here also it's employee ID. But EquiJoin, I can apply equality condition on two table. They may or they may not have common column names. If they don't have common column name, then also we can apply EquiJoin condition. So that is what EquiJoin. So different between EquiJoin and natural join is that in natural join, equality is used in common columns, but EquiJoin, equality can be used by any columns. Fine. So here I have a student table, I have an intern. Now the question is, I wanted to, so student number 1 is John, is in US, student 2 is Smith, is in Australia, while 3 is Shane, is in Canada. And while intern, if I talk about student number 1, that is roll number 1, which is of John, he is doing MBA from, and he is doing internship from United States. So when you are a student, you need to go and do internship. So fortunately, John is from United States and he's doing internship is in United States only. Smith is from Australia and he's doing BTech, but he is doing in Japan. So he's doing internship in Japan. But if I talk about Shane, Shane is in Canada, that is employee 3. So he's doing MTech, employer student 3, I'm sorry, student. And yes, he is doing internship from Canada only. So some of that are fortunate to do their internship in their own country. Some of them they don't get, they go for other country, or they explore other things. So now the question is, you wanted to find the roll number and name of those students who got internship in their own country. Now see this. Now you have to understand that you wanted to know the name of those students who got internship in their own country. So their country, they are getting internship. So as of previous table, we can say John and Shane are the two students who are doing MBA and MTech, and they are doing internship in their own country. Again, the same repetition. We don't have 3 values in our table, sir. We have multiple values in our table. So we have to apply query joins only. So fine. So now the query is, I want select student dot role, that is from student table. I want a roll number of student table. Name is only why I'm using name, because name is only in student, not here. So I can use name. So name from student and then Cartesian product with intern table. Now applying a condition where student role is equal to intern role. So intern is a table. So I have a 2 table, student table and intern table. So roll number is equal, and also student country is equal to intern country. So this is what query is. So when you apply this query, so first of all, I told you, first of all, how query execute, please make a note of it. First of all, query execute from. So from is what we are doing in Cartesian product. So first of all, Cartesian product takes place. So Cartesian product is happening. Then where condition, student dot role is equal to intern dot role. So student role is equal to intern role, yes. Student country equal to intern country, student country equal to yes. So this is selected. Now apply the same condition. Student role is equal no. So this is crossed. Student role is equal to no. This is crossed. Student role is equal to intern role, no, crossed. Student role is equal to intern role, yes. Student country is equal to intern country, no, this is crossed. Student role is equal to intern role, no, crossed. Student role is equal to intern role, no, crossed. Student role is equal to intern role, first condition is false. Student role equal to intern role, yes. Now second condition, student country equal to intern country, student, yes. So this is selected. So yes, we are getting a same good result, that 2 rows are selected, one of John and one of Shane. Now what I want from this, I want roll number from student table. So this is student table, so that is 1. And I want name, so name is John. So answer is 1 John and 3 Shane. So these, and yes, they are 2 students who are working, they are doing internship in their own country. So that is what exactly we did it. So I told you, what is cross, what is join? It's a cross join plus some condition. No, that is what this is, you get after applying a condition. And when you apply a total thing, so see how query execute, please make a note of it. Query execute, first from is executed, so this is from, then second where is executed, and then your selection executes. Fine. So after that, this selection is executed and you're getting a result. So we'll do it practically and we'll watch it how the things are taking place. So for equi-join, I have a table. So select, let me show you the table. Select star from student student of SpringPeople 1. So I've created a separate table here. So yeah, you can say that role, name and country. So John, US, whatever I've shown you is everything is here. And my one table is intern. Select star from intern, INTER intern. Yeah. Now I wanted to do, I wanted to find the name of student who got internship in their own country. Fine. So same. So select what I wanted to select. Select what student table. So I want student SpringPeople 1 is a company. From that table, I want a role, and then I also want one more column, name. So I want 2 things. I want roll number and name of those students who got internship in their own country. So this is the part which will be executed, but last, but next is from where from what student SpringPeople 1 is Cartesian product with intern table, INTER and intern table. Now I have to apply where clause, where WHERE, where student SpringPeople 1 table roll number is equal to intern table roll number and what student SpringPeople one table what country, because in student SpringPeople one the column is country, COUNTRY is equal to what intern table intern location. So INTERN intern table, what the column name is I intern loc. So INTERNLOC. So this is the complete query, very simple. So let me check. So first from will be executed. So this will be do Cartesian product will be done, 9 values will be there. So this will produce 9 values. After 9 values will apply this condition, then two I'll get a 2 rows, and from 2 rows I'll get full value, but I don't want full value, I want only these values, roll number and name. So let's see I'm getting or not. So let me press enter. So table viewer does a student, no, it said student, not student. So I have to make it student. So fine. So role, invalid identifier, ROLL. So where is what I'm making student? Yeah. So it's student, not student. Fine. So yeah, it's a typo error. Typo error. Student. Yes. So John and Shane are two students who got intern in their own country, and you can see that no. One John is in US and one he is doing MBA and got intern location in US, while two is Jasmine, Australia, but two got intern in Japan. She did not got. But three Shane in Canada and three is doing MTech and got internship in Canada itself. So yes, 1 and 3. Now we'll move to the next part is outer joins. So yes, so we talk about outer join. So let's say what is outer join. So inner joins return only matching rows. So as I told you, sometime I may not be interested only in matching rows. I may also be interested in knowing unmatching rows, no, non-matching rows also. So when you join table, you might want to include non-matching rows as well as a matching rows as well as matching and non-matching both. So you can retrieve both non-matching and matching rows using what outer join. So with outer join you can use this, and I told you we have 3 outer join: left, full, and a right outer joins. Outer join can process only 2 tables, so please make a note of it, only 2 tables at a time. Fine. While inner join you can apply on multiple tables. So we have left outer join, we have full outer join, and we have right outer join. So let's see that. The following table is a comparison of inner and outer join syntax and limitation. So these are just comparison. Table limit here in inner join you can join up to 256, but 2. Here you will get only the matching rows. Here you get matching as well as non-matching rows. Here you get matching rows value only. Here you get left value, full value, and right value. Here you can combine multiple table by using from clause. Here you use on clause, on. So here will not use from, we will use on clause. Fine. And we use where clause to specify the join criteria. Okay. So we'll use on clause. Sorry, in place of where we'll use on clause, on. Yeah. So we'll use from in place of where we'll use on clause, not from. No, we'll use from, but in place of where we'll use on. I'm sorry for that. So outer join syntax is similar to inner join, alternate syntax. General form is like this. So you have select whatever the column you wanted to select from table, and then this table, and then table 2. See, so this table will be your left table and the table. So if I'm saying table 1 right join table 2, table 1, table 2. So this is right table, this is left table. Fine. So yeah, the first table is left table, the second table is right table, and then in place of where you guys use on clause, and you whatever the condition you wanted to give you can give. So the on clause specifies the join criteria. Right. Now let's see, consider the positions in the table. Left join include all the rows from left table and matching rows. Right join include all the table from right and matching rows. Full join includes both the tables and matching rows. See, so left table is this, the which comes on left side, which I told you, and right table is the table which comes on right side of a query. And then you apply a join type. It could be a left, right, full, and then your where condition or on condition. Fine. Now see, I'm showing you the result. So table 1, table 2 having 2 columns X and A, X and B. Now you're doing select everything from left join. So left join. So table 1 will have all the values. So plus, 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 please watch this. This will have all the values. And you're putting a criteria that on 1.x equal to 2.x. So this is 1x. So table name is 1. 1x is equal to 1x. No. So for 1, we don't have any value. So this is empty. For 4, we don't have any value in right. So it is empty. So, but for 2, for 2b, for 2, so that is 1.x, x value is 2. Do we have any value? Yeah, 2x. So for this, I'm getting a value. So what exactly the thing is this? So in left outer join, we get all the left values and only the matching values from right table. But if I reverse this, you can easily understand that. In right join, so in right join, what do you get? You get all the value from right table, but only the matching value from left table, which is this. So you're getting the matching. In full, see, you get all the values from left table, you get all the values from right table, and see, this is only the matching, you are getting this. Other than that, you are getting, so see, 1a is not matching with anything, so you are not getting anything. 4d is not matching with anything, you are not getting anything. 2b is matching with 2x, so for 2b, 2x you are getting. So left part is completed. Now you come to the right part. 3y is not matching with anything, so here you are getting everything empty. 5v, you are getting 5v also, but here you're not getting anything. So yes, so you get all the values. That is for full outer join. So okay, before that, before I put one question in front of you, let me do this very quickly. So I have two tables, so let me use that. Select star from student SpringPeople 2 is a table. You can see one John US, no, whatever. And we have one more table, course, C-O-U-R-S-E, course. Yeah. Now what am I going to do? I'm going to apply a query, left outer join, right outer join, full outer join. So what? Select star from table is student SpringPeople 2 left join course SpringPeople 2 on what? You apply a common values as student SpringPeople 2 dot role is equal to, now I'm putting a criteria, is equal to course course SpringPeople 2 dot role. Here we have a common column. So table of view does not exist. So where I'm getting student. So it's student. I always make a typo error. STUDENT, student. Left outer join course SpringPeople 2 student, and then course SpringPeople 2. Yeah. So you can see that. So all the matching values 1, 2, 3 is matching with 1, 2, 3, but 5 is not. I'm not. So but it's a right table. So I'm getting, it's a left table, left join. So I'm getting all the values from left. So we do have a different scenarios also for this. So, and if I put it here right, 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 here I'll get every value of right. So if I write, so here you get every value of course 101, 102, 103, 104, but only the value which is matching in a left table. Write every value, but if you write full join, so if you write full, 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 and yes, you get all 4 values from left table, all 4 right values, and those who are not matching, you are getting a blank in front of them. That is what the thing is this. Now, after teaching you so much, I wanted to put one question in front of you. You can put your answer in the chat. You read the question very carefully, and you can see the query is, which query will display the sales ID, salesman ID, and salesman name and location also of salesmen who are co-located, means those who are living in a same place, those who are living in a same place. So you want salesman's ID, you want salesman's name, you want salesman's location, those who are living in a same place. You take your time, it will take a time, take your time, no issues. Okay, so I got one answer A, Jatin Bansal, and one B. Okay, now he's saying it's B. Okay, what about others? A very good question, a very easy question. Yeah, some is saying D, B. Yeah, see this, see this. First of all, I don't need sales table at any cost. Sorry. So I don't need this sales table at any cost. Fine. So I want all the information of sales, salesman, salesman, salesman. So ID is also there, name is also there, location is also there. And I wanted to know the name of those who are in same locations. So like Ankur is in Delhi, while John, like Ali is also in Delhi, while Amit is in like anyone which is Noida. Yeah. So if I talk about John is in Noida, Avyan is also in Noida. Fine. So you can simply go with option number what? So you are going with option number B. Yep. So you are going with option number EID, E name, E location from salesman. So you give a alias E, alias C, where E locations are equal, but their IDs are not equal, obviously. So 100%. What? Equality I want in their location. I want equality in their location, but they should be, there are different employees. So Ankur will have a different ID, while Ankur will have a different ID than what Ali. So yeah, their ID should be different. So absolutely correct. Those who are given B is the correct answer. So ID should be different while their location should be same. So that is what exactly the thing is. So over to you, Reha. Yeah.
Great. Thank you, Parul, for your invaluable insights on technology. I'm sure it was certainly a very informative session for all of you. If you guys are interested in learning more about MySQL, do check out our super discounted badges or virtual instructor LED trainings on our website, springpeople.com. These VILT trainings are leveraged online from the comforts of your home and flexible as per your schedule and location. If you do not find any suitable badges, we'd be happy to discuss and schedule private badges for you. If you don't have time to join live online, then do try out our affordable self-paced courses. For more information, do write to us at training@springpeople.com or call on our number displayed on this current slide. Now, we will open the forum to answer questions that we have received during the session. So let's get our questions answered. Over to you, Parul.